Kangaroo Math Competition, year 2013, grade 9 and 10. Question 12. The diagram shows a shape made of 6 squares, each measuring 1 cm by 1 cm. The shape has perimeter of length 14 cm. The zigzag shape is continued until it has 2013 squares. What is the length of the perimeter of the new shape? Okay. Let us look at this diagram. When two squares are joined, we have one joint. When three squares are joined, we got two joints. Okay. When a square is joined to another square, two sides join and become an internal edge. The original square lose one edge, the new square also lose one side. When there are two squares, there is one joint. When there are two squares, there is one joint. Two squares, we have four sides. So perimeter is 4, but because there is one joint, two sides are lost. So -1, -1. So 2 square, 2 times 4. One joint, 1 times 2. So 8 minus 2 is 6. When there are two squares, the perimeter is 6. When there are three squares, there are two joints. As you can see, here's one joint, and then here's the second joint. Three squares, two joints. Perimeter, 3 times 4. A square has 4 sides, 3 times 4. But because one joint, it loses two sides. So two joints, 2 times 2 sides. 4 sides is lost. So you got perimeter 8, which we can count. 1, 2, 3, 4, 5, 6, 7, 8. This to check our pattern that we are trying to establish. So when there are 4 squares, there are 3 joints. And then 4 squares, 4 times 4. 3 joints, 3 times 2. One joint lose 2 sides. So 16 minus 6 is 10. And then for the example given, we have 6 squares. 6 squares has 5 joints. So 6 squares, 6 times 4. 5 joints, 5 times 2, which is 24 minus 10 is 14, as stated in the question as example. So now, if we are forming the zigzag, we are going to add the square one by one. Every time we add a square, we have a new joint, extra one joint. Okay. So new square add 4 sides, but minus 2 sides, minus 2. Whether you join the square in this position or in the other upper part of the zigzag, it's always one joint, two sides form the internal edge. So when there are 2013 squares, 13 squares, there are 2012 joints. Like here, 6 squares, 5 joints. There are 4 squares, 3 joints, 1 less. 2013 square, 2012 joints. So if 2013 square, they have 4 sides each. 2013 times 4. 2012 joins, two sides join together, form internal edge. So 2012 times 2. That is 8,052 minus 4,024. So 4,028. Next question. We skip one question because that question not very useful. So we go to question 13. The points P and Q are opposite vertices of a regular hexagon, and the points R and S are midpoints of opposite edges as shown. The area of the hexagon is 60 cm square. What is the product of the length PQ and RS? So I draw a bigger diagram so that I can label better. So we know the hexagon lie on a circle. So the center to the vertex, the radius of the circle is R equal to the length of the side of the hexagon, also R, because equilateral triangle, hexagon are formed with 6 equilateral triangle. Then we label the distance between R and S, the distance RS as 2h. One half is h, the other half is also h. So there are 2 trapezium. Now, the hexagon area is 60. So one trapezium area is 30. We use that first. Area of trapezium, half sum of parallel sides. One side is R, the other parallel side is 2R, times distance between parallel sides, h. So we do the calculation. 3RH equal to 60, RH is 20. Then we examine the length PQ multiply RS, the product. We notice that it is 2R times 2H. So it is not necessary to find R and H separately. We know the value of RH is 20, so 4RH, 4 times 20 equals to 80. Next question. A class of students had a test. If each boy had got 3 points more for the test, then the average result of the class would have been 1.2 points higher. And the average will be 1.2 points higher. What percentage of the class are girls? Let's try to form equation. Let each boy get X points. Let the number of boys be B, number of girls be G. So one boy, 3 points more. So since it's X, then 3 points more is X plus 3. So B times X plus 3 is the total for the boys. And divided by the total of students in the class, boys plus girl, minus the score before they get 3 points more. So this is the average before adding the 3 points. This is the average after we add 3 points. So the average is 1.2 points higher. So the difference is 1.2. Now, average means marks divided by total. marks divided by total. Two averages, one before adding, one after adding. So we have Bx minus Bx. So numerator is now 3B. 1.2 is divided by 3. Yeah? So B over B plus G is 0.4. Then we know G over 1 plus G will be 0.6 because B plus G over B plus G is equal to 1. So the girl's percentage is 0.6. Percentage is times 100%, so we get 60%. The rectangle ABCD lies below the x-axis and to the left of the y-axis. All the coordinates are negative. X and y have negative values. The edges of the rectangle are parallel to the coordinate axis. For each point A, B, C, D, y coordinate is divided by x coordinate. Which point yields the smallest value from the calculation? So for this question, we just give some values. Give some values. So I label it in the diagram. So here, x minus 3, further down is minus 8. Then here is minus 2, further down is minus 5. So you can see that bigger y, y divided by x. So x value numerically bigger is better. So immediately we choose the point D. Minus 2 over minus 8 is 1/4. I think this question not very useful also. Next question. On John's birthday this year, he multiplied his age by his son's age and correctly obtained 2013. In which year was John born? So 2013 is the product of John and son age. Then we study the factors of 2013. First, before we factorize, we know that it is divisible by 3 because the sum of digit is 6, is divisible by 3. Then, because the odd position 2 plus 1 equal to the sum of even position digit 0 plus 3. So it is also divisible by 11. 2013 is divisible by 3 and 11. When divided by 3, 671. After we divide by 11, you get 61. So we know it's 3 times 11 times 61. So for realistic ages, we combine 3 and 11 at 33 and 61. So John's age is 61 and the son's age is 33. And it's a sensible combination. So to find the year he was born, 2013 minus 61, 1952. In triangle QPS, angle QPS is 59, PSQ is 60. In triangle QRS, we have RQS 61 and QRS 60 as shown. So the angles are all almost equal. 59, 60, so here balance 61. 61, 60, so the balance is 59. Which of the following line segment is the longest? This question requires you to apply the principle in any triangle. The longest side is always opposite the largest angle. This I remember I learned in Form 3, and then there is a proof for it, even the book. But most people now just accept you can prove, but we will use time to do the question. So let's show the diagram. We label the sides. Opposite Q, we label Q. Opposite S, we label S. Opposite P, we label P. Then for the other triangle, we use Q prime and S prime. Then P is common to both triangle. From here, and the principle that the longest side is always opposite the largest angle, we write the P less than S less than Q, because Q is opposite 61, the biggest angle. P is opposite 59, the smallest angle. Then for the other triangle, RQS, S prime is smallest, 59 being the smallest angle. Then Q prime is the longest side. Now that's so far we can get for applying the principle, longest side always opposite the largest angle. Then we can think of a few ideas. But then after I realized the two angles 61, 61 equal, I do a reflection, along the line SQ, so that the two angles equal will overlap. So reflect the triangle PQS, the blue triangle, over the gray triangle. So 61, 61 equal. Then from what we know here, S is less than P, so it's less than S prime less than P, so it's S prime is less than S. This side is shorter, the S is longer. Then this two Q and Q prime, we cannot conclude anything yet. Okay, this one explain why S is longer than S prime. So since the two angle equal, the two line must coincide. Coincide means P will be beyond R. When you flip over, being longer and being along the same line, P will go beyond R. And another confirmation is this 60 degrees, when flip over, is bigger than 59. So the SP will be outside the triangle RQS. The line SP will be outside. So when it's outside, and then it is then Q must be bigger than Q prime, because if you join straight, join to R is Q, you join to R is Q prime. So Q is bigger than Q prime. So PS is longest. Okay, SR is Q prime, SP is Q. You can do rotation also, I think, but since reflection, 61, 61, it makes the explanation much easier. Number 8. Ivana wants to write down 5 consecutive integers with the property that 3 of them have the same sum as the other 2. How many different sets of 5 numbers can she write? She can write 5 consecutive numbers, and 3 of them sum same as the other 2. And there are a few sets. We want to know how many sets of these 5 consecutive numbers. So for consecutive number, it is usually easier and not always. If you have 5 consecutive integer, we choose the middle one to be x, and then plus minus 1, plus minus 2. So consecutive. So we take one example to understand the question better. 3 of them, so the first 3, x minus 1, x minus 2. The last 2, x plus 1, x plus 2. Simplify, 3x minus 3 equal to 2x plus 3, x equal to 6. So the center number is 6. So we get 4, 5, 6, 7, 8, like that. Consecutive. To solve the problem, we find the total. Total, notice, because of the way we choose x to be the middle number, then the sum is 5x. And because when divided into 2 groups, they have the same sum, the total must be an even number. 5x is even because 2 groups have the same sum. So add up, it must be even. Because of that, we know the center number is even, x is even, so even, odd, even, odd, even. And we change to even as 2n instead of x. Since it's even, we put 2n, and then plus minus 1, plus minus 2. Total become 10n. And then if we take any 3 numbers, it must be 2n plus a, 2n plus b, 2n plus c, which is 6n a plus b plus c, where a, b, c is either minus 1, minus 2, 0, 1, or 2. We write that down. A, b, c are 3 of these 5 values. This must be equal to 5n, because equal 10n, half is 5n. So n, a plus b plus c is negative n. Where a, b, c must come from here. So we can see the range. The smallest will be minus 2, minus 1, plus 0 is minus 3. The largest will be 0, 1, 2. Then largest is 3. This is the interval. So there are 7 values. Okay. 7 values. These are the 7 values of a plus b plus c. Then we find that the answer is 0, 1, 2, 3, 4. But we have 7 values. So we consider positive integer. The answer choices do not include 7. So if all 5 consecutive integers are positive, so the smallest number must also be positive. 2n minimum 1, positive integer minimum is 1. 0 is not positive. So 2n more than 3, n must be more than 2, because n is integer. Then minus n must be less than minus 2. Therefore, ABC is minus n is either minus 2 or minus 3. So there are only 2 cases. So when and ABC is minus 2 or minus 3, means n is 2, then 2n is 4, the middle number is 4. So 2, 3, 4, 5. 2, 3, 4, 5, 6. When n is 3, middle number is 6, 4, 5, 6, 7, 8. And you can check the sum. 2 plus 3 plus 5 equal to 4 plus 6 is 10. Then 4, 5, 6 add is 15 equal to 7 plus 8. So we get the answer C equal to 2. But at this point, I thought of sense. There's something more we can do. 2 important points we must try to investigate. What are the 2 important points that we can try to consider? The first is when there are 5 integer, we choose 3. 5 choose 3 or 5 choose 2, there are 10 cases, 10 ways of choosing. And then there are 7 values only. So we want to see what is the actual situation, what is the nature of the question. So I look at 5 choose 3 or 5 choose 2 is 10. Then we know we have used minus 2 and minus 3. So we consider minus 1, 0, 1, 2, and 3. We realize that when ABC is minus 1, we see the center number only, then minus 2. Once we know the center number minus 2, we can form the 5 consecutive integer. So when the center 0 and then center is 2, because n is 1, then 4, minus 4, minus 6. So still not yet 10 cases, here 2 cases, here 5 cases. Where is the what is going on? There are 7 values. There are actually 10 sets because the way we can choose, there are 10 ways. Where are the other cases? When sets include 0, notice this 0 here got 0, here got 0. We can allow the 0 to be in either group. When it's minus 1, 0, or 1, we will have 0 occurring in the set of 5 consecutive integer. These 3 sets contain 0, 1. Then we can have minus 4, minus 1, 0 is equal minus 3, minus 2. But we could have chosen minus 3, minus 2, and 0 as a different group. Although the value is still minus 5, it's a different selection. So got 2 possibilities. 0 can be in either group. Whenever there is 0, you can put together with minus 2 and minus 2, or with minus 1 and minus 1. Minus 1 and 1, sorry, minus 2 and 2, or minus 1 and 1. 1, 4, 0, or 2, 3, 2, 3, 0. So this is like not just doing question only. when we do mathematics, again, we have this like inclination to investigate the nature of the system, the way the question are designed. Then you finally know why 7 is not inside. See? It can be inside one. Actually 10 sets. How many different paths are there between points A and B, only traveling along the edges in the direction of the arrow? So we draw a bigger diagram. We can label the number of ways. We label those that have one way. So from A, we can go one way here, one way here, one way here. And then here to here also only one way. One way. So there are 4 points. Only one way you can reach there. Then for those 2 ways, this point 2 ways because you can go here, then here, or here, then up 2 ways. For this point, go up and then horizontal, or horizontal, then up. For this point, we also have the square. One way, go to here, and then second way. So 2 ways. Then this one is 3 ways because here 2 way, here 1 way, 2 plus 1 is 3. We understand it by say here 1 way, 1 way, 1 way, here 1 way already. Here 1 way, here up, here second way. But because this one 2 way, you can also go up and then here. So 2 ways here give you total 2 plus 1, 3 ways. Like that. Similarly, 2 plus 1 is 3. And then this point will be 2 ways, 2 ways, 2 ways, 6 ways to reach here. 6 ways. And then finally 6 here, 3 here, another 3 here, 12 ways. Answer is 12. This type of question repeated in several types. Whether 3-dimension or 2-dimension or at condition not allowed to pass through this point, like that. You know. Rule wants to find a 6-digit number, the sum of whose digit is even, and the product of whose digit is odd. Which of the following statement about such a number is correct? Either 2 of them even or 4 of them even. Then the product cannot be odd already. All digits must be odd. So A is out. Such a number cannot exist. We know it's incorrect because we can have 1, 1, 3, 5, 7, 9. It exists. All 6 digits. The product of which is odd, is all odd. There is an odd number, odd digit. No, we have 6-digit numbers, so 6 odd digits. All 6 digits can be different, not possible, because 1, 3, 5, 7, 9. There are only 5 odd digits. When we form, we must have 1 repetition. Therefore, answer is E. None of A to D is correct. One over 1,024,000 is written as a decimal with the smallest possible number of digits. How many digits appear after the decimal point? So this number, we want to find the exact value, will be very troublesome. Take a lot of tedious calculation. So we must find a better method. How many digits are? We know 2 power 10. This one is all must learn up. If you don't know, but I think you all already know. Is 1024 is 2 power 10. So if I take 1 over 1024, that means half power 10, 0.5 power 10. So 0.5 multiply 0.5, 10 times, it becomes 10 decimal. If 2 times, 0.25, 2 decimal. 3 times, 0.125. 3 times, 10 decimal. So if we add 30, you must multiply 0.001, 1 over 1,000. So 3 more zeros in front. Okay, 10 decimal times 3 decimal, 13 decimal. Example, if 2 decimal times 2 decimal is 4 decimal. Okay, so just add 10 plus 3, 13. 13 decimal. Answer 13 digits after the decimal point. A lot of zeros. Okay, next question. How many positive integers are multiples of 2013 and have exactly 2013 divisor, including 1 and the number itself? So we will treat the question by doing a smaller number first. Understand the type of thinking required in the question. We said 30. 30 is 2 times 3 times 5. It has 8 divisor. We can easily write down 1, 2, 3, 5. 6 is 2 times 3. 2 times 5, 10. 3 times 5, 15. Then 2, 3, 5, 30. 1 and itself included. So we want to find the general principle. The divisor 1 is because all the power is 0. When the divisor is 2, then 2 power 1. When divisor is 3, 3 power 1. 5, 5 power 1. Then 6, we got 2 and 3 power 1. Then we have 10, 2 and 5 power 1. 15, 3 and 5 power 1. And then all power 1. Meaning the power is either 0 or 1. When we have one factor, it is either used or not used in the divisor. 6 is a divisor. 5 is not used. Like that. So use or not use, so 2 ways times 2 ways times 2 ways, there are 8 ways. So 8 divisor. That's the principle. So how to find the number of divisor? We always look at the exponent. Suppose you got the number and the prime factor, EQR are prime factor. Then we look at the exponent. When the exponent is 1, 1, 1, then there are two ways, 0 or 1. When the exponent is A, then it's, let's say 3. Then it's either 0, 1, 2, or 3, like that. Yeah. You can use it, don't use it one time, 1p only, or p square, or p cube, if A is 3. So always one more than A. So the number of divisor is formula. Use the exponent, add 1, add 1, add 1, and multiply. It will be the number of divisor. This is the formula for finding the number of divisor, so that we don't have to write out the divisor if a lot. Now we want multiples of 30 that has 20 divisor. Suppose you want 20 divisor. So multiple of 30 means 30 times some integer. Then it's 2, 3, 5. So the number of divisor is always A plus 1, B plus 1, C plus 1. But we want it to be 20, so we must equal to 20. If not, it will not be 20 divisor. So we can only say it's 2 times 2 times 4. That means A is 1, B is 1, and C is 4. As one possibility, A, B, C not allowed to be 0. If 0, then 2 is not in the product. Then how can it be a multiple? Like 1, 2, and 10 not allowed. If this is 1, then A is 0. Then 2 power 0 don't have 2. So it's not multiple of 30. 1, 4, 5 is not allowed. So minimum must be 2, 2, 5. 2, 2, 5. But there are 3 ways. There are 3 multiples of 30 with 20 divisor. Because we can have 1, 1, 4, or 1, 4, 1, or 4, 1, 1. And we notice that the value is 3750, 810, or 240. They are all multiple of 30. Okay. So first we must know the way to count the number of divisor. Then if we want 20, we make it 20. Okay. Suppose I want 9. Then you say no such thing. If you want 9, then you must have 133 or 119. But when 1 A is 0, B is 0, this minimum must be 2, 2, 1. So we want 9 divisor, cannot simply any number of divisor. Even 21 divisor also cannot. Because 21 is 3 times 7 only. Then you must be 1 times 3 times 7. So you cannot have multiple of 30 that has 21 divisor. Not possible. So now they do the question. Okay, 2013 is product of these 3 prime number. Then we choose a multiple of an integer n, which is 3 power p, 11 power q, 61 power r. Okay, we must choose like that. I will prove at the end of the question why only like that. Now we do first. So if we have 2013 times n, multiple of 2013, then the power exponent become A, B, C. And we want to have 2013 divisor. So A plus 1, B plus 1, and C plus 1 must be 2013. The number of divisor is like that. And this happened to be only 3 prime factors. So we can have A equal to 2. 2, 10, and 60. 2, 10, and 60. Okay. So that we have 3 times 11 times 61. 3 times. Yeah. So, but then we can move around like just now, the exponent. There are 3 values of A, B, C to be shared with the prime numbers, with the prime factors. So there are 6 cases, 6 cases. A 2, 10, 60, 2, 60, 10, or 10 to 60, 10, 62, or 60 to 11, 60, 60 to 10. Where got 11? 10, 60, 11, then 2. Okay. So there are 6 multiples of 2013 with 2013 divisor. Number of divisor is sure 2013, but there are only 6 such number. Answer is D. Now, we know how to find the number of divisor. There's also a formula for the sum of the divisor. We do that one first. Formula for the sum of the factors. We know how many factors. We also have a formula for the sum of the factor. Suppose our number has prime factor P, Q, R, can be more. Sum of the factors 1 plus P square until P power A. Then for Q until Q power B, and for R until R power C. And you've got some more, we just continue. So this is a formula for the sum of the factors. So 2 things. One is number of factors, one is sum of the factor. So for 30, we know answer is 8 divisor. But sum of the divisor, 1 plus 2, then 1 plus 3, and then 1 plus 5. And then P is 2 only, then we stop already. Power is 1. 2 power 1, 3 power 1, 5 power 1. 72, which we check. 1, 2, 3, 5, 6, 10, 15, 30, end up is 72. Okay, this example, another example will be better. Suppose we got cube and square. 8 times 9, 72. What is the sum of all the divisor? We see cube, we form the series until 2 power 3. We see square, we form until 3 square. Then we have, this is what? 27 plus 30, 34, is it? 27, 30, 34 times here, 9, 13. Oh, not 27, 8, 8, 10, 15. So 195. So if we really write out and check, it's 195. How come like that? Why is the formula like that? See, this 1 is multiplied to all the divisor of power of 3. And then this 2 also multiply to all. 2 square not multiply to all, and 2 cube multiply to all. So 2 cube 3 square will be inside. 2 square 3 square will be inside. And you form the series like that. All the factors will be inside when we expand the bracket. So that's the concept to find the sum of the divisor. Okay. Just now I say, if we try to be funny, we say n is a multiple, n may have some other prime factor. Okay. Why we only choose 3, 11, and 61 only in the solution? We only choose 3, 11, 61. I can add multiple, I can have other number. There's another thing we want to study. So then the number of divisor must be 2013. But 2013 is not any number. They only got 3 prime factor. So one of the factor must be 1 if you got 4 bracket. So A must be minimum 1, must have 3, must have 11, must have 61. So this one, 2, minimum, not 2, 3, 11, and 67. So this one has to forced to be 1. Forced to be 1 means D is 0. D0 means don't have the extra prime factor. Then at first I was doing this question. I say, why never want to put or not? Want to put or not? And I do first without putting it. Then I try, because it will be forced to become 0 1. So yeah. So can other prime be included? No, cannot. Okay. Several non-overlapping isosceles triangle have vertex O in common. Every triangle shares an edge with immediate neighbor. The smallest angle at O is M. And then the other triangle will have size 2M, 3M, 4M, 5M, and so on. Several. So the diagram show only 5. Then the question wants as many as possible, so that the smallest value of M, the angle. So the smallest is M, 2M, 3M until K triangle, not 5. We want more than 5. So we add 1 to K is K over 2, K plus 1. Since the answer 1 to 8, we want to divide by don't know which number. Is it 1 or 2 or 3, 6 or 8? Then after we divide, it must be consecutive. The number must be product of consecutive number. That is why I arrange the equation like that. I saw the consecutive. Hope that it can help to solve. So if I divide 1, 2, 3, 6, and 8. So I get 720, 360, 240, 120, and 90. Then how to check easily? How to check with without much calculation. We look at K times K plus 1 is approximately K square. So K square approximately equal to these 5 values. So if we square a number, You don't need to square root. With 26 square is smaller than 720. 27 square is 729, is more than 720. So we cannot have 26 times 27 already consecutive, cannot. This number is out. Then 360, 18 square, 324, 19 square, 361. So the two consecutive multiply cannot be 360 out already. Then we check. We realize 15 square, 225, 16 square, 256. 15 times 16, 240. So K is 15. And then K plus 1 is 16 and M is 3. Answer M is 3. We can also see that 120, you can have only 10 times 12. But 90, we can have consecutive. Then K is 9, M is 8. 9 times 10 is 720 over 8. But when K is larger, M is smaller. So answer M is the 3. It is the smallest. 8 is an answer, but it's not the smallest. So this kind of idea, you see consecutive, you can approximate as square. And you can see that it helps to simplify the amount of work to eliminate. Okay, Julio creates a procedure for turning a set of 3 numbers into new set of 3 numbers. And each number is replaced by the sum of the other 2. For example, 3, 4, 6, you get 4 plus 6 is 10, 3 plus 6 is 9, and 3 plus 4 is 7. So you get a new set of 3 numbers. How many times must Julio apply this procedure to the set 1, 2, 3 before he first obtained the set containing the number 2013? Is it 8 times, 9 times, 10 times, more than 10 times, or 2013 will never appear? So we try to form a few cases. If 1, 2, 3, then smallest is 3, 4, 5. We arrange in order from smallest. 3 plus 4, 7, 3 plus 5, 8, 4 plus 5, 9, and then 15, 16, 17, 31, 32, 33. So you see any pattern already? We notice that the middle number is 2, 4, 8, 16, 32. So the middle number in each set is a power of 2 when arranged in increasing order. This one, the example, they never arrange. We arrange, then we get the middle number is 2, 4, 6, 2, 4, 8, 16, 32. So power 1, 2, 3, 4, 5. When you reach here, is how many times already processed? 1 time, 2 times, 3 times, 4 times. Okay, procedure 4 times. Power is 5. 2 power 10 will be inside. We know it was. So when 2 power 10 is the middle number, then 1023 and 1025. So the next set will be 2048. Double 2 power 11. So because of this, 2013 will never appear. It jumped already, overshot. Answer E. So nowadays the recording is posted in the YouTube. You search for BH Core, my channel, BH Core. Okay. So end of lesson. Okay. Stop here. Stop share.